How does Amadori rearrangement create browning and flavor? Imagine biting into a perfectly toasted piece of bread or savoring a grilled steak. What makes those foods taste rich and look appealing? The secret lies in a fascinating chemical process called the Maillard reaction. Within this process, a key step is known as the Amadori rearrangement. This step is like a hidden switch that turns simple ingredients into complex flavors and beautiful browning. Here's how it works. When you cook foods that contain sugars and proteins, like meat or bread, the heat causes a reaction between a reducing sugar, such as glucose, and an amino acid. They first form an unstable compound called a Schiff base. Think of this as a temporary link that's ready to change. The Amadori rearrangement then takes this unstable compound and transforms it into a more stable form called the Amadori product. This is a specific compound known as a 1-amino 1-deoxyketose. This transformation is important because it sets the stage for many other reactions. As the Amadori product forms, it begins to break down into smaller molecules like reactive carbonyl compounds and Strecker aldehydes. These molecules are like building blocks that further react to create a variety of flavors and colors. For example, they produce compounds called heterocyclics. These include substances like furans, pyrroles, and pyrazines. These are responsible for the roasted, nutty, caramel, and umami flavors we associate with cooked foods. Another reason the Amadori rearrangement is so vital is that the products it creates are more stable than some later Maillard compounds. This stability means they can act as flavor precursors or even additives, helping maintain fresh-tasting qualities in foods. Factors like temperature, pH, and moisture influence how quickly and effectively this rearrangement happens. That's why roasting, baking, and frying, methods that apply dry heat, are so good at producing those appetizing browning and complex flavors. In essence, the Amadori rearrangement is like the first domino in a chain reaction that leads to the rich browning and deep flavors we love in many cooked foods. It converts simple sugar and amino acids into a stable intermediate that then breaks down into a multitude of flavor molecules and brown pigments called melanoidins. This process is fundamental to creating the appealing look and taste of everything from roasted coffee to baked bread and grilled meats. When you understand how this step works, you can better control and enhance the flavors and colors in your cooking.